9, 8, 7, 6, 5, 4, 3, 2, 1.
Ten, nine, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello! Welcome back. Another day, another episode. Cracking the code interview with Rust. Rust Lang, Rust programming. What a thrill, what an exciting day. Beautiful day out there here in New York City. That's what it looks like outside. Welcome back. If you're tuning in again, I realize nobody's watching this, but welcome back anyway. That's funny to me. If you're tuning in for the first time, then thanks for dropping by. Thanks for watching. We are cracking the coding interview. We're gonna crack it with Rust. Rust is a cool language. It's fun to learn. I've been forcing myself to learn it by going through the problems in this book. So thank you, Gail McDowell. It's a really long name, even longer than mine. I've always felt my name is really long, but anyway, thank you for the book. We're doing the problems. Doja's crying. Why are you crying? What are you crying about? No crying. One puppy that's got everything in the world. Everything. All right, well, let's get into it. Yeah? So, picking up where we left off last week, I think the last problem I was on was, chapter 3, problem 2. And I remember, I didn't solve this problem correctly. I would say I failed it. If I had been asked this in an interview, I would have probably failed that interview. And at the time, at least, I couldn't figure out what the proper way to implement. I'll read the problem in a minute and explain. But anyway, it didn't occur to me, of course, until like an hour after when I was like, oh yeah, of course, It's really simple. So to get started, I'm gonna go back and finish that problem that I didn't finish last time first. As well, a quick recap just of where we are, where we've been. Let's see. So there are 189 problems in this book. I think there are what, 17 chapters? Is that right? How many chapters? Yeah, 17 chapters, 189 problems. We are in chapter 3, making our way through it. I've done everything up to chapter 3, problem 2, except problem 2 is not actually complete. So let's quickly revisit problem 2. Let's look at the book. Problem that we were trying to solve was this stack min. There we go, stack min. How would you design a stack which, in addition to push and pop, has a function min which returns the minimum element? And then here's the catch. Push, pop, and min should operate in constant time. Order 1, constant time. Right? Okay. So I got hung up on that constant time thing. Now, let's switch the code here. Close OBS. So I was thinking way too hard about this problem, trying to solve it in constant time. It's actually really simple because you can just use a stack to keep track of the minimum elements in order. And the reason I got hung up on this is because I was thinking that in order to do this correctly, I had to keep track of the order of every element. But that's actually not true. All you need to do is know which is the current minimum and which would be the next minimum if that one were removed. And because the structure itself is a stack, things can only be added and removed in a particular order. And because of that forced ordering, it makes this problem actually really easy to solve. So let's do it. Let's solve it. I forget how to write code. It's been a couple hours since I did any of it, but it's always weird, like getting on here and trying to talk and write code at the same time. It's just like a different mindset, I guess. My brain needs to be in a different mode in order to do it right. Okay. Very simple. Let's do this. All right. So on push is really easy. So we have to change the min here, first of all, to be a vector of type T as well. And change this to a vector of type T. Yeah. Just like that. So basically, let's look up Rust vector. I just had it there. So I mean, the vector in Rust already implements a stack for you. It gives you a push and a pop. So there should be a last. Is there a last? There we go, last. There's also, you can also get a reference to last element. So we don't really need to actually write any code here. All I need to do is this. If min dot length, wait, is empty? There we go. If min is empty, then return none, else return sum of the minimum element. Boom. All right, that's min, easy peasy. Implemented. Why? Oh, last is returning an option. I can just return that. Okay, cool. It should be self.min. Okay, I think that's done. Waiting for all the squiggly lines to go away. There we go. All right, that is done. And this is simple. I'm gonna do this slightly differently. I'm just gonna rewrite this and say if self dot min, so if it's not empty and this new value is less than self dot min it's confusing because I have a min, which is a function, and min, which is also a a member. Self.min. Whoops. Actually, I think this. Yeah, this is returning a option ref. So I can just do unwrap, self.min unwrap, just like that. Then I would just say self.min.push, push the new value. That's it. Right? Oh, sorry, this should be min.last, min.last unwrap. Okay, make sure that, there we go, no squiggly lines. All right, and then pop. Okay. So pop is a little tricky because so you need to pop off the element first. Do that. All right, that happens here. First line in the function, get the result, and then you need to check pop against the minimum, and then you also need to check the value of pop, and then you also need to check the next value. So if you imagine that you just popped off the minimum value, although it just occurred to me this is maybe slightly trickier than I thought, because yeah, you could have the min value repeated. Yeah, right? So if the min is repeated, if the minimum value is repeated, that's a good question. I didn't think of this. I didn't think about this. Well, hold on. Let me just implement this guy here. So, okay. So let result equal blah 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 pop. Okay, and then here it'll just say clear. So basically, if it popped off the last, element in the stack, I can just clear that out. Now, if the element I'm popping off is, hold on, let me check something. This is tricky. So I think the way I need to do this actually is to use less than or equal to here on the comparison, because if you imagine a case where like you push the number 1, and then you push the number 2, and then you push the number 1 again. 1 is the min. So when I pop that 1 off, I don't want to remove that 1 from the min stack necessarily if I only have it in there, right? So in other words, you have to duplicate the values if they're equal in the min stack, I believe. This needs to be a clone. Okay. Right? Does that make sense? I think it's making sense. Anyway, so okay. So then I would say if the current minimum value, if that, whoops, is equal to the result. Okay, take that, unwrap it. Like that. Then pop that off. Pop. And then that's it. I think. Let's run the test. Nope, doesn't work. Blew up. Why did we blow up here? This can be else if. Where did it blow up? 345. Let result. Hold on. Called unwrap with a none value. Where did that happen? No capture. Okay, where am I? Oh. So this could be none. Else if result is sum. That wasn't it. Where else am I unwrapping? Push. So if min is not empty, it's probably this. It's probably blowing up on the push here because this should just be if self.min.is empty or, and then these two. There we go. There we go. Okay, boom. That's it. Did it. Ordered 1. All right. Let's check that in. Git commit. Make C03 P02 O. Boom. Well, that's it. That's it for that one. Let's move on to the next problem. Yeah? All right. Let's have a look. What is next? What do we got? All right. Just looking at my messages. All right. What is the next problem? The next problem is called stack of plates. Wow, that sounds fun. Stack of plates. Imagine a literal stack of plates. If the stack gets too high, it might topple. Therefore, in real life, we would likely start a new stack when the previous stack exceeds some threshold. Implement a data structure set of stacks that mimics this. A set of stacks should be composed of several stacks and should create a new stack once the previous one exceeds capacity. Set of stacks.push and set of stacks.pop should behave identical to a single stack. That is, pop should return the same values as it would if there were just a single stack. Follow up. Implement a function pop@index, which performs a pop operation on a specific substack. All right, sounds pretty easy, to be honest. Let's do it. Stack of plates. Stacks of stacks. Stacking sats. I'm stacking sats every day, but I don't need to tell everyone in the world about it constantly. I guess I do sometimes, tweet about it, but you know, I guess I should minimize the passion as much as possible. Copy problem 2 to problem 3, chapter 3, problem 3. Okay, did that. Cargo test. Cool. Okay, stack is basically the same, except get rid of min. Okay, goodbye min. Don't care about you. Thanks for dropping by. Let's get all these calls to min out of here. Min, 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 min. Min, and that should all pass. It does. Bingo. All right, so our stack here is going to change slightly such that it is a stack of stacks. And then let's add a new parameter, which will be capacity. Yeah, okay. Capacity. Usize, and see if there's a Rust vec. I wonder if there's a nice way to allocate an array here. Reserves capacity for at least additional more elements to be inserted in the given vector. The collection may reserve more space to avoid frequent reallocations. Okay, so let me just look at the problem again. It starts a new stack when the previous stack exceeds some threshold. So it doesn't really define what they should be, but let's just say yeah, capacity, whatever, that's sufficient. So I will basically just initialize this with one vector like this, and with a particular capacity. Where's the new? I want like a new with capacity. Yeah, okay. Vec t with capacity, like that. Okay. And then here, this is going to be self array last mutable push. And then pop is going to be the same, but last mutable unwrap. I think this needs to be last mutable returns reference. I can use a map here. That's probably cleaner. M. Let's make this A for array, like that. I think that's good, right? Sweet. And then here, basically the same thing, but I would just say self array last mutable map A, and then A dot top. Right. That should compile. Expected type, found type. Oh, whoops. Had a semicolon at the end. It's no good. I believe this returns an option. Yeah, sweet. Expected parameter. Oh, this returns an option to an option. I can just unwrap this guy. Too many options. Right? Map. Rust iterator. Map. Unwrap. I wonder if there's a shortcut. Yeah. Collect, like, kind of what I want, but no, filter map. Iterating over results. Can I just do filter map? Is that gonna do what I want? Meh, whatever. Okay. That should, oh dear. This should be new. Say capacity 10. I need to store this capacity as well. Capacity, keep track of it. Usize. Capacity. Expected one parameter. There we go. All right, that runs, that works so far, so good. So far, so good. Let's call map F on an option where F is unit closure. Figured I wasn't doing this right. Quick fix. Peak problem. Called map F, where F is a unit closure. I know what it's complaining about, but I don't know how to fix it. So let's see if it tells me how to fix that. This one. Yada yada. The correct usage would be option, do stuff. Example. Checks for the usage of option map, where F is a function or closure that returns the unit type. Readability. All right, fine. If let blah 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 equals A. Close this. A dot push value dot clone. All right, is that better? Are we good? Are we happy, Clippy? Are we happy, Clippy? Happy little Clippy. Why? Oh, this should be some. Oh, my syntax doesn't make any sense here. Sum A equals my brain. My brain's not a good one. It's like a little pigeon in there. That's a function. All right, there we go. That sort of works. What was the other function it said that we should implement? Implement a function pop at index, which performs a pop operation on a specific substack. Okay. I think it probably wants me to do an if let on this guy too. If let sum A equals blah blah blah. A dot pop. Else none. Okay, like that. Like that, like that. Like that, like that, like that. Like that, like that. What was it again? Pop at. Okay, function pop at. Mutable self and some index. Index usize. I'll return an option of t. Okay. If the index is less than self dot array dot length, then do it. Otherwise, don't do it. This is going to basically be the same as this, except instead of array dot last, it's array index. Like that. What did I do wrong here? Array. Okay, can I just say get mutable like that? Is that better? There we go. There we go. Push one. Stack with stacks. What was this called? Goku 00. Hello, welcome to the stream. We're stacking plates here. Stacks. What is it? Stacks. Stack with min. Place that to stack. Hey, use where to state the traits the type should have. Right? Yeah, I believe so. I believe where is to define the traits that are required for your generic type, whatever that is. Stacks, set of stacks. Sorry, this should be called set of stacks. Set of stacks. Replace all. Boom. Set of stacks, pop at 0. Yeah. And let me rename this guy to stack set. Cool. Have a test. Boom. All right, let me make sure that this is actually working. So I set my capacity to 10. So let's do a for I in range, or actually I of 0 to 100. Set of stacks, push I. Dot pop. Results equals blah blah blah. Do I need this iter here? There's a range. I want it to be an iterator, right? Rust range. I don't know if I've ever used the range. Can I just treat the range itself just as a plain old iterator like this? Must be it. No. Rust for range. Oh, no, I can do that. For n and yada yada. Okay. No, that's right. Okay. We're good. So here I want the result, so let result equal pop, unwrap, and then assert equal I result. That should be it. Run that. Mess something up. Missing a close brace. Boom, done. That works. That is working. Bingo. Amazing. Let's do another test here where I say, do this again. 3. Okay. Set of stacks. Push. Blah, blah, blah. Actually, this can just be, or no, put that code back. Put it back. Go up to 20. Okay, push, and then I should be able to say set of stacks pop 0. Let pop at, well, it's puppy dreams. Pop at result equal pop at 0. Unwrap, and that should be equal to 9, right? Assert equal pop at result 9. Gotta go test. Oh dear. I'm not handling the capacity. Forgot to do that. I never implemented that. Okay, so push. Let me do for this first. If self.array last.length, the length of the last array is more than the capacity, then add a new array. Add a new array. T with capacity. Should be self.capacity. It should be self.array. as ref self.capacity, like that. So if this thing's at capacity, add a new array. Okay. And then here, it's basically the reverse of that. If the last array self, well, actually there's two conditions. If this array, sorry, the length of this array is greater than 1 and the last array is last as ref is empty, then pop the last one. Self array pop. I'll do this. Let turn value equals that, and then turn that. Self array last. Why is it? Yeah, there we go. So it needs a semicolon, and I think we're there. I think we did it. Maybe. Nope. No method name is empty for option. Oh, I need to unwrap. Might be easier to just use an if let here. If the length is greater than 1, and then if let sum a equal yeah, whatever. I'll leave it as was. I don't know if that's actually any better. And this is fairly succinct. It's pretty clear what I'm doing here. If the last, unwrap the last, yeah, good enough. Cargo test. Oh dear. Oh, this needs to be unwrapped. Boom! There it is. We did it. We did it, team. Fam. We've done it. We've accomplished problem 2. I just realized this is not problem 2. This is problem 3. But I just edited the file called problem 2. So I'm gonna have to do a little swap-a-roo, switch around. Okay, copy this to derp, and then move problem 3 to problem 2. Yeah, and then move derp to problem 3. All right, close that. Problem 3. Oh man. Here we go. Cargo test. I think we're done. Stack set. Did it. 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 Yep. Maybe I should pop off what remains in this and check that it's right. For I in, I did what, 20? So it's gonna be 0 to 20. In reverse. And then this, but I'm gonna skip 9. If result is equal to 9, continue. Cargo test. Oh dear. Pop at Pop out result. What am I missing? What did I miss here? I missed something. Versus if I, this should be if I is equal to 9, that's right, okay. Oh dear. Left 7. Did I pop twice? Oh, I pop at. Pop at. I think I also need to check in pop at if this guy's empty, and also remove that. So I would say if self dot array index is empty. If that guy is empty, then I also need to remove it. And I can just do self. I remove on a particular index. Remove self dot array dot remove index. Okay, let's that be the return value, and then return that. Okay, still failing. Something is wrong. Something's wrong in the codes. So if I is equal to 9, continue, skip over that, right? Oh, I need to do this before I pop. Okay, driver test. Boom, there we go. The test was wrong, code was right. I guess the code was still wrong. If the test is wrong, the code is wrong, right? How's everyone doing out there? Having a good weekend? Yeah? No? Maybe? Let's see what the next problem is. What's the next problem? Next problem. So that was number 3. Oh, let me check in my code here quickly. Get status. Get add that. Get log. Copy the format. Get commit. Problem 3. Push it up. Hope I didn't have any clippy errors in there. I might have. I don't know. Let's take a look at the build. Build history. Should be building right now. There it is. Cool. So let's just copy this right now. Copy, paste. Problem 4. Let's close problem 3 this time, so I don't try using that again. And let's look at the book. Let's go to the book. Problem 4. It says queue via stacks. Okay. Here's the problem. I can't see the screen right now. Just a sec. There we go. Queue via stacks. Implement a myQueue class which implements a queue using 2 stacks. A queue using 2 stacks. Okay. So what is the difference between a stack and a queue? you may ask? Well, a stack is a last in, first out data structure. LIFO, last in, first out. A queue, on the other hand, is a first in, first out data structure. FIFO, right? I think that's really the only difference. What did it say this should be called? My queue. Burp, excuse me. Okay. And it's supposed to use 2 stacks to do this. My queue. Why did that fail? Let's try this again. My queue. Alright, that failed. Sometimes VS Code sucks balls, like when trying to rename something. Stack set. My queue. No, just replace. Replace all. So let's change these method names from add, or actually let's call it queue. Oh, let's just do add and remove. Remove. Okay. I don't need pop at. Get rid of that. Let's make this add. Remove. Okay. I think RLS broke again. We don't need this capacity. Get rid of that. I think we don't need it. I'm not really sure how to implement this just yet. I gotta think about it. One moment. Okay. I wasn't sharing the right screen. Forgot to do that again. All right, so how do we implement this? Implement a queue using 2 stacks. How does a queue work? You push something into a queue, and then it exists at the end of the queue. And then when you pop something off, it then exists at the start, or it's, yeah. So it says using 2. I'm not sure what it's getting at there, but if I were to take a wild guess, I think it may be suggesting that you use you use 1 stack to reverse the order and copy that into the other, if that makes sense. So right. So if I have a stack and I want to remove everything from it in the opposite order, right? I can take my stack and pop it and then push it into another stack. And then I think pop the values off that stack and they'll come out in the opposite order, right? Like you're reversing the order. I think. I think that'll work. Okay, I'm gonna take a 5-minute break, and then we'll come back and we'll try to solve this. Yeah, sound good? All right, BRB. All right, I'm back. Do I have my microphone on? I think so. I think it's working. So I was just thinking about this problem and how silly it is. I think, given the only hint in the book is that you're supposed to use 2 stacks, I think the only solution is to reverse the stack every time using the other stack. It's kind of wild wild and crazy, but whatever, so be it. Let's do it. How's my sound? Maybe I should... Yeah, I hear stuff. You can hear it coming through. Let's do it. QVS stacks. Switch my screen. Let's have two stacks here. I'm gonna call them forward, reverse, like that. Okay. Let's just make these empty, and then self. So add, we'll add it to our little forward, whatever stack. So the way this will work is every time I want to remove an element, I'm going to iterate over each of, or actually I'll basically just do this. I'll say while self.forward. While this is not empty, I would do reverse.push forward.pop, just like that. Okay. And then I would say let return. Value I'm going to return is reverse.pop. Like this. Yeah, that's fine. And then basically do the reverse of what I just did. This should be self. Actually, you know what? I can just keep this like this. And then just like the other stack can just be a temporary. Although it's like, and this is so silly, but it doesn't even make any sense. You could also just use a reverse iterator. Although this is not, I mean, this is a vector in Rust, so it's kind of meaningless. I just boiled some water for some tea. I'm gonna go grab that. Drink some tea. Hot tea. Hot tea. Boiling hot. Piping hot. Drinking that. Drinking my tea. These cameras are so wide, they just make everything look super distorted on the edges. It's crazy. Crazy, crazy distortion. Okay, remove that guy. All right. Let reverse, call this mutable, reverse equal vec of t new. Okay. So while this guy is not empty, push all that into there. This value I'm going to return, and then here just say, well, the reverse one is not empty. Self array, whoops. Push. Reverse pop unwrap. Boom. That's it. Whoops. Go test. Sweet. I got some clippy errors I need to fix. Come back to that in a minute. All right. For I in 0 to 10 set of stacks. Let's rename this set of stacks to my queue. Replace all. My queue dot add I. Okay, and for I in 0, 10, my queue dot remove dot unwrap assert equals I. That's basically it. Cargo test. Boom. Done. Okay, let's see what my clippy errors are. Add clippy. A little buddy clippy. Buddy pal, buddy friend. Oh, there's no issue. Okay. Gotta add the problem. Add chapter 3, problem 4. I think that's the one I just added. Also, my build failed the last time. Yeah. Cargo format. Jeez. Run cargo format. Push that. That should fix the build. All right, let's pop over to the book. See what the next problem is. There's only 2 problems left in chapter 3. We're flying through chapter 3. Okay, the next problem is called sort stack. Gee, I wonder what it's about. Focus, please. Here we go. Write a program to sort a stack such that the smallest items are on top. You can use an additional temporary stack, but you may not copy the elements into any other data structure such as an array. The stack supports the following operations: push, pop, peek, and is empty. Okay. Push, pop, peek is empty. Push, pop, peek is empty. All right, so we got a sorter stack. That's fun. Push, pop, peek is empty. Let's see. So it said we can use an additional temporary stack. So this is going to be similar, I think, to problem 4. Let's just copy problem 4, by the way. Copy problem 4, paste. And we're on problem 5. What do we call this? Sort stack. Rename my queue sort stack. My queue with sort stack. Okay. So let's rename these. Push, pop. So it said sort stack. Write a program to sort a stack such that the smallest items are on the top. Okay, so I think what needs to happen here is that it's going to be quite similar to what I did before here. However, in the previous problem with this like reverse situation, but a little different. So ordered, let's call it there. I'm going to move my temporary up there. I'm going to do the popping here. So I'll just leave it like that. Array pop. Whoops. Cargo test. Let's test that. Whoops. Yeah, I got rid of remove. Renamed it to push. Pop. Push. Switch stack. Pop. Cool. Test fails. That's fine. This is right. It's right that it's failing because, yeah, the order will essentially reverse when I put this stuff in. So the way this will work is pretty simple. It said in the book that I am allowed to use peak. So I think this is kind of like a crazy version of bubble sort. I think what I'm supposed to do is find the min, find the smallest element, and so hold on, let's think about this for a sec. It says I'm allowed to peek. Presumably peek means yeah, I think peek in this context means that I'm just looking at the book here. It has like an example stack implementation in here with peek, and in this example, peek returns the first element, but it does not remove the element, right? So, what does the question ask again? Sorry. Write a program to sort a stack such that the smallest items are on the top. You can use an additional temporary stack, but you may not copy the elements into any other data structure, such as an array. I can copy them into the stack though, and a stack is an array. I hate to break it to you. Well, it's usually implemented as an array. I suppose you could implement a stack as a linked list, but we're not doing that. Okay, so I'm going to do the ordering on push here. That's my plan. Now, so here's what would happen. So when you add the new value, it's going to first of all, check if there's nothing else in the stack, then you just add it and you're done. That's it. So if self array, if it's empty, then just push, you're done. Just like that. Okay. Yeah. My RLS broke again. Let me restart. Okay. So if it's empty, push done. That's it. Otherwise, so this is very simple. All you have to do is check if the new value, so if this value is less than or equal to the current top, which is last. If that's the case, then just push. Easy peasy. Just like that. Okay. If it's not, then we make use of this temporary right here. So then we say self so as long as this value is greater than this value. No, sorry, I have this backwards. Yeah, as long as this last value, like the top, is greater, right, than the new value we're inserting, then this needs to be outside the loop. Okay, then we'll just call this temp. Terribly overused variable name. Okay, temp push self dot array dot also need to check that this is not empty. Well, this is not empty, and the last value, unwrap, should do as ref unwrap. Okay, then temp push pop unwrap, like that. And then once we're here, I'm just going to do a push of this value, and then push everything else from the other array. So while temp is not empty, self array push temp pop unwrap. Boom. Boom. Just like that. Unwrap. Okay. Cargo test. I have too many. I think I need to make that a ref and this a ref. Although I don't want to, if I just do unwrap here. All right. Can I just deref that guy? There we go. Boom. I think that's it. Clippy. If has identical blocks. That's true. Let's just change this to an OR. Just delete, 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 delete. If array is empty or cool. Cargo test, cargo format, get status, add that guy. Problem 5. Push that up to the Git hub. I love the name Git. Linus, Mr. Torvalds, Captain Linux. He says he named Git after himself. If you didn't know, Git is an impolite term, pejorative term for a not so smart person, I think. I think it's like British slang, isn't it? tfd.com/git. TFD stands for the free dictionary, look it up in in dictionary. Git, British slang, an unpleasant, contemptible, or frustratingly obtuse person. Yeah, I guess that's me too. That's how I see myself. All right, that build's running. Let's see, we only have one problem left in this chapter. So let's do it. Let's just bang it out. Let's get it done. This one is called Animal Shelter. Ooh. Okay. Let's have a look. Animal Shelter. An animal shelter. I wonder if Gail here cares about animals and shelters. Does it say anything about her interest in animals there? Focus? No, give up. Okay, animal shelter. Animal shelter. That's what I operate here. My apartment. It's an animal shelter. Really, for just one animal. My little pup. She wants me to hurry up and finish this problem, so I'll take her to the park again. Animal shelter. An animal shelter which holds only cats and dogs, well, that seems discriminatory, operates on a strictly first in, first out basis. People must adopt either the oldest, based on arrival time, of all animals at the shelter, or they can select whether they would prefer a dog or a cat, and receive the oldest animal of that type. They cannot select which specific animal they would like. Create the data structures to maintain this system and implement operations like enqueue, dequeue any, dequeue dog, and dequeue cat. You may use the built-in linked list data structure. Okay. Cool. Well, seems pretty easy. Well, let's jump to the code. My build passed. So you can see. Oops. Close OBS. Build's good. It's all green. I love a green build. It's a very satisfying feeling knowing your stuff's all green. It's hot tea, real hot. Okay. So, says strictly first in, first out. Also says I can use a linked list. I'm not going to use a linked list because this is Rust. And here in Rustland, we're not really using linked lists that much. Unless we absolutely have to, like for coding puzzles or whatever. So let's not use a linked list, but let's definitely use an array. This is pretty easy, I think. What I'm going to do is create a small struct to represent the animal. And it's just going to be a dog or a cat, and then I'll give it a name, I think. Yeah. So we'll have in Q, DQ, DQ, dog, DQ any, DQ dog, DQ cat. Okay. And then I suppose we're supposed to be concerned about the order. You may use the built-in linked list data structure. I kind of want to peek ahead to the hard problems section and see what some of those problems are. It's probably just going to be like Boggle 20 different ways. Hello. I'd like to just solve Boggle again. The 10 millionth time. Sure, okay. That's basically every interview I've had in a nutshell. Okay. What are we doing here? Pet shelter, animal shelter. So I got a couple ideas for doing this. One is to maintain 3 different stacks or queues. Another is to maintain 1. Really, the problem doesn't actually make any statements like rules about it, so I'm just gonna go with the most obvious one here. Okay, calling this animal shelter. It's just gonna be an array. Okay, and I need to, so it's slightly more tricky because you essentially need to queue and then dequeue a specific type. So I'm not going to make this generic. I'm going to make this animal shelter, and then I'm going to have an animal struct up here. Struct animal. It's going to have a type enum. Animal type. It's either going to be a dog or a cat. Okay, type, animal type. Then let's give it a name. Its name is just going to be a string. Okay. say kind. Type's a bad word because it's special. Maybe let's say species. Species. Is that good? This doesn't need to be generic. Okay. Animal shelter. Partial equal. Partial ordering. I don't actually think I need these wheres anymore, right? Binary option equals. I think I need to implement all of the same for all of these to make that work, right? Derive all the same guys. There we go. Okay. Let's actually just delete all this. So let's just do let's rename this to animal shelter. Place all. Delete all these tests. Delete this. Delete that type. Delete that, delete that. Okay, we're there. We have the basic animal shelter now. Okay, so we're going to implement 4 methods: enqueue, dequeue_any, dequeue_dog, and dequeue_cat. Okay. Function enqueue. That's just going to take in my new animal. Just an animal. Okay, that doesn't need to return anything. And then dequeue_any. Okay, that's going to optionally return an animal. And then same but for cat, dog. These all need self. Should be mute self, mutable self. How are we doing now? Can we get rid of all the squiggly lines, please? Squiggly red lines? I think we're good. Just make this return none, just so that I can get no red lines. I just want no red squiggly lines. Okay, I think this is going to be the last problem like this that I do today. Maybe I will, maybe I'll come back later in the afternoon. I don't know. Don't really have anything else to do. I guess I could like work on some other projects or play some video games or something. I haven't done video games in a while. Okay, enqueue. So enqueue is pretty simple, right? Just gonna go self.array.push animal. Yeah, this guy can just take ownership of that thing. No problem. You can have that. You can own it. We're good, right? Animal shelter.enqueue animal name Peter. Species animal species cat. Peter the cat. Make sure that works. Squiggly lines. Go away. No red squiggly lines, please. ToString. Cool. That does not blow up. That is good. Problem 5 is the right problem, right? Ah, crap. This should be problem 6. Mess it up again. All right, let's copy this, paste. Now we're on problem 6. Close problem 5, and then let's go revert these changes I made to problem 5. Yeah, discard changes. Okay. Add this problem 6. There we go. Cargo test. There we go. We're good. We're good. All right. Add Peter the cat. Let's add Jamal the dog. Let's add Caitlin the cat. What's a name that people like? What are some good names? Caitlin, Helen, the cat. There we go. Cargo test, cargo format. Okay, got some animals. Cat, dog, cat. Maybe add another dog. Julia the dog. There we go. That's good. So let's implement this guy. This is really easy. Just gonna say self array well, what is it to get the no, I don't want train. I want to remove the first element. Can I just say remove? No, not that one. Appends an element, moves first. I want to just remove first. Removes the first. Boom. No. Let's just do. Let's just use remove. Just remove with a 0. DQ any. First, I need to say if self dot is empty, and just none else. Remove 0. That returns T instead of that. So, okay, there we go. cargo test, cargo test. Okay, let's make sure that let first equal animal shelter dot remove any, unwrap first dot species. Let's do first name should be equal to Peter. Sweet. Okay. All right, and then in this case, simply going to find the first in the array. So we'll just do for rust iterator enumerate. Or why don't I just do like each iteration next. Find takes a closure. Because find takes a reference and meta iterators. Basic usage. Okay. I don't know if I want to use that because basically I'm looking for the I'm looking to like find an element and then remove it. I wonder if remove item says it's nightly. I'm just gonna use enumerate with index. That's probably the best way to do this. Okay. I, comma val, for that in self.array.iter.enumerate. Okay, and then if val dot species is equal to animal species dog, then made a mess. What did I do? There we go. Okay, return that. We can just simplify this to be like that, I believe. Oops. Sweet. Let's test my dog. Let dog equal animal shelter DQ dog. Dog, get me a dog. Unwrap. And my dog should be, who's my dog? Dog.name should be, so Peter's already out. Next one's Jamal. Oh, I should make this, I should do cat first. Because, yeah, let's try getting a cat. So cat should be Caitlin. Okay, we can also just copy this function and make it DQ species, and then add that there. Let's make that generic, and then we can just do like that, like this. Oops. Cargo test. Boom. All passing. Cargo test. That's it. Let's add maybe couple more cases. First, what is this one? This one should be, we've got Peter, Jamal, and Caitlin out, so this should be Helen. Next. Boom. All right, let's fix my warnings here. Let's add Harry Potter. Let's add Hermione Granger, who's a cat. Should have put Crookshanks in. Haha. Okay. And then animal shelter dot. Let's add Ronald Weasley as well. He can be a cat, any dog, cat. I have to fix camel case to snake case. Okay, fix all those. Cargo test, cargo format. That's it. Done. Cargo status, get status, get add dot Let's do it. Let's add the final problem here. Problem 6. Push that up to the repo. Well, we did it. We did it, team. We're done. We just finished chapter 3. End of chapter 3. What a thrill. Let's take a little look ahead here, see what chapter 4 is. Chapter 4 is trees and graphs. Cool. What a fun time. Trees and graphs. There's lots of search stuff happening in here. That's cool. I want to skip ahead to the advanced section and just see what's in it. I haven't really looked. I want to see what the hard problems look like. Let's maybe just read one of the hard problems from the last chapter. Let's see. Chapter 17. Hard. Let's have a look. These are some of the problems. Here's one. Max black square. Imagine you have a square matrix where each cell pixel is either black or white. It's hard to pull the book in a non-awkward way. Alright, focus. Focus, please. Focus. Please focus. Please focus. Please, you piece of junk. Please focus. There's nothing else for you to focus on but these words, so just focus on that. It's like focused on the wall behind me, but not the book. How do I make you do what I want? Camera? Why is your autofocus algorithm such garbage? There we go. Given an n by n matrix of positive and negative integers, write the code to find submatrix with the largest possible sum. Sparse similarity. The similarity of two documents, each with distinct words, is defined as the size of the intersection divided by the size of the union. For example, if the documents consist of integers, blah, blah, blah. Cool. I guess those are hard ones. They don't really sound that hard, but then again, I haven't tried to do them yet. I guess we'll get there. We're not there yet. Wonder how many times boggle is in here. Wow, there's a lot of them. There are 26 in the hard section. Add without plus. Write a function that adds two numbers. You should not use the plus or any arithmetic operators. I've done that before, so that'll be fun figuring that out again. Cool. Chapter 12, C and C++. Looks like a bunch of questions just quizzing on C++. Fascinating. All right, so chapter 4 will be the next, which is trees and graphs. I'm not going to start chapter 4 right now, but let's take a look at the first problem in chapter 4. Route between nodes. Given a directed graph, design an algorithm to find out whether there is a route between two nodes. Cool. We're going to do some Dijkstra, A-star search. I guess it doesn't say anything about optimizing, but all right. Well, that's it for now. Thanks for watching. Thanks for tuning in. Hope you had a good time. Hope you learned something. please be sure to smash that thumbs down button and unlike, unsubscribe, unfollow me on Twitter, and leave a nasty comment as well while you're at it. Thanks for tuning in. Hope you had a good time. Have a nice weekend. Maybe I'll see you later. I might pop on here again in the afternoon. We'll see how I feel. Ta-ta. Bye for now.